Så, kära travelare, dear guests, dear friends, and special welcome to Professor Harrison Schmitt. We're really looking forward to hear your speech. And you have not come to Sweden because of the Swedish weather, that's for sure. But you are most welcome. Please. Guest here, the honorable guest, which is your colleague.
Yes.
He didn't went so far as you did, but at least far enough.
But long.
Crystal Finkelstein. So, Professor Harrison, Professor Smith, sorry, floor is yours.
Thank you. Tusen tack för dig. Ska vi snacka lite om månen? Jag var i Norge för flera år sedan. Men jag har glömt mycket norsk, and I never learned svenska. What we're going to do tonight is take a very rapid trip to the moon. First via a PowerPoint presentation that will begin here, and then maybe a little more dynamically with a DVD that was prepared a few years ago that summarizes what in film what I will try to tell you first. But first of all, it's probably wise to remember the Apollo program and the context in which it was conducted. This now took place 40 more years ago. And the landing on the moon was first proposed by President Kennedy in 1961, but the process of landing on the moon began somewhat earlier than that. Of course, the first stimulus that really energized the United States space program was the Sputnik, the launch of the first artificial satellite of the Earth by the then Soviet Union. And by 1958, President Eisenhower and the Congress had agreed to create NASA, the National Aeronautics and Space Administration. It was created out of an organization known as the National Advisory Committee on Aeronautics, the NACA, and that was very fortunate because the principals in the NACA had already managed very complex aircraft programs, particularly the X-15. It was being run at that time by Robert Gilruth and Chris Kraft and George Lowe. These names may be familiar to some of you. They really were the people that turned the idea of going to the moon into reality. It was, though, and we must remember that, to counter the Soviet advances in human spaceflight. That was directly part of the major contribution of the Cold War between communism and democracy of that time. And was a very important factor in it. It really did, some Russian emigres as well as others believe that it was the catalyst that created the environment in which the Cold War ultimately ended. Now, Neil Armstrong successfully landed on the moon in July of 1969, and this, from a formal perspective, ended the moon race. There were 5 additional Apollo missions that landed on the moon between 1969 and 1972. Indeed, between December of 1968, when November of 1968, when the Apollo 7 launch occurred, that was an Earth orbit test of the Command and Service Module, and November of 1969, there was a launch of effectively a moon mission every 2 months by a rocket we will talk about more in a moment, immensely successful rocket. The last 3 Apollo missions each explored the moon for a total of 3 days, 21 hours each. And each of those missions had a lunar rover that you'll see shortly that enabled a much more broadly effective exploration than the previous missions, even though all the missions returned excellent suites of lunar samples for us scientists to work on. And that work continues today. There were some 385 kilograms of lunar rocks brought back to Earth, and you would be amazed at the amount of work that continues. There's a Lunar Planetary Science Conference going to happen next month. It's happened every year since 1970, and it continues to amaze me how much work is being done by new generations of scientists. How they're getting paid, I have no idea, but we'll leave that some other way. And what all of this is giving us, and continues to give us in an increasingly sophisticated way, is a new understanding of the Earth's history. This is the science return that we got for what was originally a purely geopolitical mission. But fortunately, the people such as I mentioned earlier who were managing the program realized that if they had the capability to go to the moon, they had the capability to explore the moon. And that made all the difference in the world within the context of the Apollo original purpose. That history, of course, is a history that's obscure to my geological colleagues here on Earth because the Earth is a very active planet. Now, Sweden's in an area, a shield area we call it, that's not quite as active as other parts of the planet. But if you look at what's happening around the Pacific Rim, you can see that the Earth is still very, very active and changing itself. And it has obscured this early history. After about 3.5 billion years ago, things changed a great deal. Before that, and during a period in which life was evolving on the planet, we had no insights about the environment of the inner solar system during which that was occurring until we went to the moon. And what we discovered was an extraordinarily violent period in the history of the solar system, but still life found a way. Now, life found a way to learn how to survive, too, in the Apollo days. We had thousands of hours of training in simulators, of course, and aircraft and helicopters and the like, and all the Apollo people, including myself, had to be jet pilots and helicopter pilots, and as well as spacecraft pilots. But there was still uncertainty in those early days of whether the mission coming back to Earth would actually land exactly where it had planned to land. And the possibility was thought to exist that we might end up in the jungle, as you see here, or in the desert, or out in the water somewhere for several days. And we had survival training and all that. And here in Panama, you see some very young-looking astronauts, although. And coincidentally, the gentleman on your left, Ed Mitchell, just passed away on the 4th of February. Yeah, and on the eve of his landing on the moon with Al Shepard. Ron Evans passed away many years earlier. On the right, he was our command module pilot on Apollo 17. Yours truly somehow still gets invited to make talks such as that. And if I ever need another career, it looks like I could handle myself. Now, the first mission to the moon was crewed by Neil Armstrong, Buzz Aldrin, and Mike Collins, and they are in this picture. Mike on the left, Buzz on the right, Neil just in front of him, and a couple other much younger astronauts in between. Now, as far as Neil's mission on the moon, there was, for some reason, Neil made a decision that he would handle the camera for most of the time on the moon. And as a result, you see many pictures of a second-generation Swede, namely Buzz Aldrin, but only one, as far as we know, of Neil Armstrong, and this is it. Mm-hmm. And Neil, at this point, is filling a box, a vacuum seal box, with the samples that he collected. And by the way, he collected one of the finest suites of samples of any of the missions in a very short period of time, about 20 minutes. But he told me later, as we worked together on other projects, that the box looked awfully empty when he had put all those rocks in there, and so he filled it with dirt, with lunar soil. And that sample, 100080, we all know what its number is, has turned out to be one of the most valuable samples for those of us who think that there is a potential for a private venture on the moon producing energy from its soil. And that sample that Neil collected is our primary case in point. The two missions that are bookends, if you will, of the Apollo landings on the moon, Apollo 11, Apollo 17, landed about 600 kilometers apart in two different basins, and came away with very different pictures of what the moon was like, which has been integrated, of course, into the other missions. This particular picture I took on the way back to Earth, and we had not quite left the vicinity of the moon to the point of where we couldn't see some of the far side, and the right-hand portion, say third of that picture, is the far side of the moon. And a famous crater, one of the first photographed by anyone, in the case the Soviet spacecraft, Tsiolkovsky is down in the lower right, just coming into sunshine. Now, what made all of this possible was the Saturn V rocket. The Saturn V was initiated about a year and a half before President Kennedy made his announcement that we would go to the moon. It came as a result of a great deal of technological work done at the Army's Redstone Arsenal in Huntsville, Alabama, by Werner von Braun and others who had come out of World War II. But Eisenhower told the then administrator of NASA, T. Keith Glennon, who had previously been president of Case University, a very famous technical university in America, that he should begin the development of what was then called the super booster, and that basically was the Saturn V. And so that all started, fortunately, in terms of Kennedy's challenge to get to the moon before the end of the decade of the 60s. Fortunately, we had a head start with the rocket that made it possible. Now the building there, this is actually the Apollo 17 Saturn V, rolling out to the launch pad, out of the vehicle assembly building. That's the big building there behind it. And to give you some perspective of just how big, that is a very large fire truck right there. So at the time it was the largest enclosed space in the world. Now the spacecraft that we used were situated in the pointy end of that rocket, the lunar module in what was called the SLA, and I can't remember what that acronym stands for, I'm sorry. Somebody even in this room may remember what it is. And also the command and service module in which we were residing during this period was up in the very top of it. The pointed rocket right on top of the Saturn V is the launch escape tower. It was for a period of time, about a minute during the launch, we could be pulled away from an exploding rocket with that launch escape tower. After that, we would fly away from it. But fortunately, none of that ever happened, even though we were prepared for it. Now, if you look carefully on the left-hand side of the rocket, you see a great deal of debris seemingly coming off. Those white flecks here, they're actually very large pieces of ice, of frost. We had to wait on the pad for about 2 hours and 40 minutes after the planned launch time in order for a computer problem to be worked out in the launch computer. And it turned out not to be serious, and certainly something that could be fixed. But during that time, out of the humid Florida air, the frost accumulated on the cold sides of the rocket. Remember now, there are fuel tanks in there of liquid hydrogen and liquid oxygen that make the rocket itself quite cold. However, right at this point, there's very heavy vibration, low frequency vibration that is enough to cause essentially all of that ice to come off the rocket. So we didn't have to carry that penalty into space. We carried a little bit of it on the this rocket up here, the S4B, that injected us into lunar orbit. And when we, after that injection and it shut down, a little bit of ice started to float along with us towards the moon. What happened to that ice, I have no idea. But it was really quite spectacular at the time. Now, you've seen this picture before. I only show it again, not to emphasize how much some of us have aged, but to illustrate some of the of another spacecraft. We often forget that the spacesuit itself was a spacecraft. It had oxygen, water for cooling. We had water-cooled underwear, by the way. That's how we stayed cool while working in that suit. It had a power supply, communications, everything you could expect a spacecraft to have, except it was shaped more or less like a human being. And it had even mobility because we were inside of it, right? And we're able to move it around. Now, if you ever experience getting into one of these suits, one clue is that anything that's blue here, anodized blue, represents an input to the suit. Communications, cooling water for that underwear, fresh oxygen, and the like. There's even one of them, this one right down here, is an input for emergency oxygen. We had a high-pressure oxygen bottle, you'll see later on our backpack, that would supply emergency oxygen. Now the red is what is our exit ports that would go back in one case, back into the portable life support system to be cleaned of carbon dioxide, and in the other case would be purged directly into the atmosphere in order to provide circulation if you ever needed that emergency oxygen supply. Oh, and by the way, later on you'll see a Hasselblad camera on the front of the suit, and that was attached to that, I guess this isn't going to, there we go, it was attached to that bracket right there. Now, we're on our way to the moon, and one of the first things we had to do was go into Earth orbit to check everything out. 90-minute orbits around the Earth, it's slightly under 18,000 miles an hour. And here over the South Atlantic, had a chance to take a few cloud pictures, but I want you particularly to notice that band of blue above the horizon. That, of course, is our atmosphere, and just keep that in mind for a later picture. I had planned to take a great number of pictures and observations of weather patterns in the southern hemisphere on the way to the moon whenever our other duties permitted. And I did do that a great deal. This is the first main documentation picture I took of those early patterns that I saw. And now it turns out this is the most requested picture from the NASA archives. Used in advertising everywhere. And for other purposes as well. That is a hurricane, typhoon going ashore on the subcontinent of India. The intertropical convergence zone that Christer has seen again and again and again from Earth orbit is there. And here, though, not quite a full Earth, the Mediterranean there, and the South Pole right down there. Fortunately for weather observations, the absence of main continental masses in the southern hemisphere give very symmetrical patterns around the source of the weather, and that is, of course, the Antarctic continent. Now, this is a picture I want you to remember, that band of blue, because it doesn't exist around the moon. There is no sensible atmosphere around the moon. This picture was taken just after we went into lunar orbit. It's a lunar sunset. Actually, the spacecraft was for us, it was a lunar sunrise. We were in what astronomers call a retrograde orbit, and I'll let you ask your grandchildren or children just what that's all about. But this is not a bad representation of what things look like. Slightly tan in the sunlight in this particular case, and very dark in the shadows. The Apollo 17 mission was targeted to the Taurus Littoral Valley, a 50-kilometer long valley that you see on the right here. Those mountains on either side rise to 1,500 to 2,100 meters. And so the valley itself is deeper than the Grand Canyon of the Colorado in the United States. It's a remarkable place. And we were able to land right there due to the remarkable navigation capabilities that were developed for the Apollo program and are used today in many different respects. The other spacecraft with our colleague Ron Evans in it was there taking navigation sightings of small craters near the landing site whose position we had determined through photogrammetric techniques relative to the center of mass of the moon. Now that's very important to be doing your orbital mechanics relative to the center of mass, of course, and really enable the actual landing in this valley. Otherwise, we would not have had nearly the precision necessary to do so. The camp that we set up on the moon, you see here, the Challenger lunar module, landed on December 11th, 1972. And this is a picture I took as one of many panoramas of the area in the first excursion, or our extravehicular activity period, so that we would document as best we could the landing site before it became disturbed by our activities. On the right here, you see the ladder that we use to get in and out of the spacecraft. Now, this is everything you need in order to work on the moon. You need the camp that I've already mentioned. A lunar rover certainly helps. It enabled us to drive 35 kilometers around the surface of this valley. And at one point, we were about 7 kilometers away from the lunar module itself. And of course, the other spacecraft with a human being inside of it, you see there, yours truly having his portrait taken for whatever posterity exists. The only problem we had with the lunar rover was getting fenders broken off by commanders of the mission. This seemed to happen on all 3 of the missions that had the rover. For a variety of reasons, but with the great help of our friends down in Mission Control Center, they came up with a repair that took about 5 minutes. We put these unneeded photo maps together with gray duct tape, as you might expect, and clamped them on the fender with an unneeded photo map, unneeded clamps for lights in the lunar module. It worked very well, and the reason it was important is that driving you in 1/6 gravity, you get, which is the gravity of the moon, 1/6 Earth gravity, you get just enough rise of the dirt off the wheel that you get a forward rooster tail. You get dust coming ahead of you, and some of that filters down on the rover itself and on the crew, and it's just a nuisance. It really is a nuisance. So. And it takes a lot of time to dust surfaces that need to be thermally controlled and like. So repairing that fender was quite important. Fortunately, it didn't take very long. Not for us. It took all night for the people in Mission Control to come up with the best way to do it. There's now the spacesuit in use. The backpack you can see. There's a bag for samples on my side of the backpack here. This is that emergency bottle that I mentioned up there. The Hasselblad camera, of course, is right there mounted on it. People often ask, how in the world do you keep pointing that so well? Because all the pictures are pretty well pointed, and you just learn. We practiced and practiced and practiced taking those pictures until it was very natural to point your chest in the right direction. I'm taking a sample we call our rake sample. That is actually a sieve that collected particles that were greater than about a centimeter or two in diameter, and we expected to find exotic fragments in that sample, more so than just in the ordinary material. That worked pretty well, except I won't go into it right here. It didn't work at all here, except we had lots of good samples of basalts. The only difficulty in using that suit, physical difficulty that I had, was in the glove. It's a pressure glove. It's 3.7 pounds per square inch inside the glove, and every time you squeeze it, it's like squeezing a tennis ball. And so for 8 hours, you're working these muscles in your forearms. And we just did not have enough insight in our training to really prepare for that, like the crews that have gone to the ISS, the International Space Station, have done. But we got the job done, and it worked out very well. The walking in the suit was, I found the best way to do that was to use a cross-country skiing technique. Just a toe push and glide across above the surface rather than on it, and that works very efficiently and very well. And you probably could sustain 8 or 10 kilometers an hour for quite a period of time doing that. This large boulder had rolled down the side of one of the mountains from about 1.5 kilometers away. We had seen the boulder on pre-mission photography. It was big enough for the resolution of that early photography to pick up. And so we planned to go there. It's a very important geological station for us. I'm there for scale only. But if you look carefully, that's the light spot over there is the lunar module sitting in an area that's been winnowed away a little bit by the descent engine, so it becomes lighter than the rest of the surface. And here you can see my footprints going down into the trench behind the boulder that led up to its source. And those footprints actually will stay there for about 1 million years, maybe 2 million years in recognizable form. The only erosion on the moon is the impact of very small meteors, we call them micrometeorites. And the only continuous erosion is that, and that will gradually garden the surface so they'll disappear. This is a fairly steep slope. It's actually about 20-degree slope that the rover is parked on. One of the many geological discoveries of our mission was the discovery of volcanic ash, this orange soil that you see in this picture. Really turned out to be very important and still is. Many people working on it, including myself. But one of the most recent discoveries, because of the advance of technology over 40 years, is that within these little tiny beads of glass that constitute this ash, there are small crystals of olivine, and within those olivine there are little concentrations of lunar water. So this material was the first definitive indication that the moon has water inside it, and that has some significant implications to understanding the origin of the moon. Standing around in your underwear on the moon is not something that most people would think you do, but it was the most comfortable that we had, particularly as the spacecraft got warm, as the sun rose slowly in the east. And that picture really doesn't prove that I was on the moon, but to me it does. Outside the spacecraft, I had a chance after the second excursion to take this picture through my window, and it shows how we had begun to stir up an otherwise pristine surface with our activities. The surface itself has very high bearing strength initially, but as you work on it, it gets stirred up. And the future settlers of the moon will have to figure out a way to stabilize those surfaces, and I think there are a number of options there to do that if you're going to stay any length of time. The metallic cones there on the right are small restartable rockets. They had about 50 pounds of thrust each. We had 16 of them spaced around the spacecraft in order to control its attitude as we flew through space. That 50 pound thrust is contrasted with the 1.5 million pounds of thrust of the engines in the first stage of the Saturn V. So there's a tremendous spectrum of propulsion technology that was required in order to make these missions possible. Well, we left the moon after about 75 hours on the surface, almost 22 hours outside the spacecraft. And this picture is not a very good one. It was taken off the television monitor where the television had been parked about 300 meters away just for this purpose to watch the liftoff. The commander asked me to go out, or suggested that I go out and get a really good picture of liftoff, but I declined. Fortunately, and it means I could be here with you tonight. Now, we have a spacecraft in orbit around the moon right now called the Lunar Reconnaissance Orbiter, taking extremely high-resolution pictures of the entire moon. It's a work in progress, but a great deal is being learned as a result of having these higher resolution pictures, even about a place that you visited. I'm just in the process of publishing a paper on how this Lunar Reconnaissance Orbiter imagery has helped understand the geology of the Valley of Taurus Littrow. Here you see that our tracks, my tracks going out, this set right here, wandering around looking for a good place to deploy the science experiment package that was deployed right there. The lunar rover is parked over there. That's where that picture was taken from. And you can to get an idea of the fine resolution of these pictures and see these rover tracks. Those wheels, you've already seen them. They're only about this wide. So they've stirred up dark material from underneath that light surface that was caused by the descent engine effluence. The ascent engine of the Challenger, the ascent stage of the Challenger returned to rendezvous with Ron Evans and the spacecraft America. Ron had been conducting a variety of experiments in the spacecraft while we were gone. This is maybe the first space selfie, for all I know. He is demonstrating here a problem of some small consequence that we had, and that is that our water was produced by fuel cells. That is oxygen, hydrogen fuel cells that combined over a catalyst to produce electricity and water. But some hydrogen always ended up in the water, and here Ron has succeeded in getting that hydrogen to coalesce into a bubble in a bag of salmon salad. And some of you are aware the salmon salad was fine. There was nothing wrong with it. It wasn't spoiled or anything like that, but it was not the most delectable food that we had in the spacecraft. In fact, the best food we had was irradiated food that had been irradiated with gamma rays to kill off the bacteria. The Army, the U.S. Army had developed what they call wet packs for long-term storage of food, and they were quite good. They had fruitcake, believe it or not, was excellent, high-protein fruitcake. We had hot dogs, sausages, and peanut butter, and I think that's it. I think I gave you all of them. Yeah. And those disappeared very fast. Anything that had some taste to it disappeared very quickly. Your appetite is reduced, at least initially in space, ours were, and you crave spice. And I think that's mainly because NASA took all the spice out of the food. They didn't want any untoward effects of having that spice in you, and that's another story. Well, we entered the atmosphere at about 25,000 miles an hour, just about the speed that we left. These parachutes, big chutes, were deployed at 10,000 feet. We had splashdown near almost exactly where we had planned to splash down, and to the minute of the time that was scheduled for splashdown. And the Ticonderoga was sitting out there, an ASW carrier, waiting for our arrival. Actually waiting for us about 5 nautical miles away, just to make sure we didn't have a carrier landing. Because our navigation was better than the Navy's. There's a story that about in the early missions, one of the mission controllers, without talking to his boss, had requested the Navy, and the Navy complied, that they park a nuclear submarine under the carrier. So because the nuclear submarines had very precise navigation. He got in some trouble for that when NASA got the bill for the nuclear submarine on deployment. A good friend of mine, he was quite a character. Anyway, we ended up being picked up by the Navy SEALs and moving over to the carrier. Well, ladies and gentlemen, just a quick revisit to the moon here with the astronaut, the mountains of the moon behind, the flag of the United States, and the Earth above it. But I show this other picture of an Earthrise from behind the moon is just to remind us that as another generation goes off to Mars, this may be one of the views that one of the parting views that they have of the Earth as it rises over the moon. And I feel very strongly, and I know others do as well, that the fastest way for us to move on into space, to get to Mars, is by way of the moon and using its resources, as well as learning again how to work in deep space. So it's probably about time we took another walk on the moon. And with that, we'll move from this presentation over to the DVD, if in fact it's queued up. This DVD was produced for one of our anniversaries. It is a very quick move through the Apollo mission, beginning with some recorded quotes from the very commanders of the various missions as they moved their flights through space. The Apollo 10 mission, which you saw the logo of there, was a precursor to Apollo 11, landing there, not landing on the moon, but going very close and exercising all of the procedures necessary to land on the moon. And of course, the last of the three missions, Apollo 15, now 16, and then 17, were the culmination of the actual exploration of the surface of the moon. This film was put together by friends of mine in Canada, the Apogee Books people, Bob Gardner. Now, we'll see this again a little bit later in the film, but this is some team sampling of the volcanic ash that I mentioned earlier in the presentation. We did not only the training that we discussed earlier, but our geological training. Once a month, we would spend 4 or 5 days on simulated lunar field exercises, but on real geological problems. That made a big difference in the training, I think, of the pilot astronauts in particular, as they begin to assimilate just how geologists work on complex problems. You've already been indoctrinated on the jungle training, and our efforts to guide a raft down the Chagos River in Panama. The crew of Apollo 17, Ron Evans, myself, and Eugene Cernan. Ron suiting up, very enthusiastic young man. And here Al Shepard is trying to talk to me through my helmet. I don't think that ever worked. I don't remember what he said, but we seemed to enjoy ourselves. Headed for the van that would take us out to the launch pad. I seem to have forgotten where the elevator was. I finally realized that there, and now in the van I decided maybe this wasn't a good idea. Charlie Buckley was not about to let me out of that van. What's called the White Room, it's where the people strap you into the spacecraft, and believe me, they strap you in. They get in there with you and put their foot on your chest and make sure all those straps are as tight as possible. And you want it to be, not only because of this heavy vibration during this stage of the flight, but also because at staging, that is when the first stage shuts down and the second stage ignites, you go through a sequence of plus 4.5 Gs to minus 1.5 Gs to plus 1.5 Gs, all in less than a second. Just a second and all of that happens. Now we're all weightless. This period of time when I probably was spending most of my time looking out the window, watching the Earth recede from us. That sequence that you'll see here in a moment of from the full Earth to about a 2/3 Earth by the time we reached the moon. Since we were in a lunar reference trajectory, what they call lunar, we were watching the Earth turn every 24 hours. So that gave us an opportunity to see this kind of a sequence of pictures. There's Australia, the beacon of the South Pacific. Almost never any clouds on Australia. And I'm sure they, except when there are big floods, and they tend to regret that. There's the Valley of Tarsalisso once again. The Command and Service Module moves me across. Now we're undocking from the other spacecraft and headed towards the moon. Now what I want you to do is watch the bright spot right here. That's what's called zero phase point. Now there's the shadow of the Challenger just coming out of that big crater called Camelot. And as you get closer, as we get closer, you'll start to see the streaming of the dust that I mentioned earlier. Always some dust. There it's streaming, and then we had our touchdown. This is a set of pictures, a panorama of some of the pictures we took out of the lunar module windows. Now, the deployment of the science packages were largely up to me, while the commander drilled a series of holes for heat probe, heat flow measurements, and also to get a deep core, about a 3-meter core. He asked me to come over and help him, and I was not asked to come back. Maintaining your balance was always a bit of a problem. Here I was carrying a sample bag, doing some solo sampling, which normally we did not do. We worked as a team. And I dropped the bag, and some of the samples had come out. And getting up is not that much of a problem. You just lean back and let the suit sort of spring you up. Remember, it's a press suit, but hanging onto that stupid bag. And then I start to get into trouble. And about this time, I was informed that by the capsule communicator that the Houston Ballet Society would like a little more professional demonstration, and so I decided to give them a little bit more of a show. There we go. But I still ended up with the camera in the dust. So I'm sure Victor Hasselblad, if he was watching, was very upset with me at that point. This is a panorama actually taken off the television camera, so you'll see both of the astronauts in this. This is over where we found the volcanic ash, looking at a crater known as Shorty. And Rob Godwin, who put this whole thing together, was able to produce some very nice panoramas. You saw this earlier, but it shows you how the team usually worked in sampling. The commander was holding the bag, and I was getting samples of various aspects of this volcanic ash deposit. That scoop turned out to be one of the best sampling tools that we had. Not only could you dig a trench with it, but it enabled you to do some very, very precise sampling. We used a geological hammer fairly frequently, but only when we were working on the large boulders. There now is another view, slightly different coloration of the orange volcanic ash. Beneath that ash were layers of black volcanic ash. There had been a number of eruptions in the valley about 3.5 billion years ago. And we talk about big numbers when we talk about isotopic dating of the moon. This is what a microscopic thin section looked like. Down in Houston, they were getting very excited about this. In fact, Jim Lovell, the commander of Apollo 13, was in that picture. The pilot astronauts, rather than taking my advice to learn how to cross-country ski, like to hop across the surface, like you see here. Now remember, this is a 20-degree surface. This is up near that big boulder, and I guess that's some defense that it was difficult to maintain your balance. Now this is another one of the color television panoramas that was put together. It shows different stages of the astronaut activities. As you can see, the panorama itself was taken over a period of time. Now, I had done some sampling up in a small crater near that big boulder. I had my visor up so I could see better. That was a sun protection visor. I didn't normally look into the sun, so I wasn't too worried about it. But you don't see many faces of people on the moon, so I'm glad I did that. Now I'm practicing some of my downhill skiing. I needed another pole, I caught an edge there, but ultimately really had even though we were working and doing things we had to do, you could have a very good time on the moon. 1/6 gravity is very pleasant. It's like walking around on a giant trampoline. I don't know how many of you have been on trampolines recently, but that's about as close a description of 1/6 gravity as I can give you. Now he's padding in on the Challenger, the lunar module out there in the distance. We were about 4 kilometers away at this point. Again, a panorama from the television camera that has been printed. This is near a crater we named Van Serg after a professor of mine at Harvard. It also is where I really can give you a good demonstration of that toe-to-toe movement, even through a boulder field. I had a lot of confidence in my ability to control my emotions here. The spacesuit obviously has gotten very dirty by this time, and it didn't seem to affect the thermal control significantly, but it did cause difficulties in the cabin because that dust was all brought in. We tried to brush it off, but that was just another way of getting your arms tired. It didn't work very well. The liftoff, you've already seen a still. This is the actual picture that the television camera transmitted. We had about a half an Earth G acceleration, which was more than enough to get us started into orbit. Looking back down with this, a film camera now, this image was taken from film camera, and it just fades into the picture you saw earlier from the Lunar Reconnaissance Orbiter. That cross that was there, if you noticed it, was an antenna layout that we had for a radar experiment. And in this picture, you could sometimes see the firing of those attitude control thrusters. Now this is television, cabin television, that watching Ron Evans move out to gather some film canisters. We had a series of cameras and other radar experiments and others in a scientific equipment bay that he operated for all the days that we were down on the surface, as well as other times. I was monitoring his umbilical there. His oxygen supply was coming through that umbilical. And I'm down, there's my head right in the left of the picture right there. Now a more dynamic view of splashdown. The Ticonderoga was called into service to pick us up unexpectedly. It actually had 6 months before was being decommissioned in dry dock, and they suddenly needed that carrier and its capabilities in the Vietnam area, and so it just happened to be in the right place at the right time to be our recovery ship. I believe that was yours truly coming up in the basket, because I was the only one at the time that had dark hair. That's how you tell. Now you can see that we were all having to readapt to Earth gravity, wandering around on the red carpet from one side to the other. I don't think anybody actually got off the carpet, but it was a challenge. Saying hello to our various welcome committee there, the Captain Green, who was the captain of the Ticonderoga. Barry Goldwater actually was on the ship and came to see us and come back. Well, ladies and gentlemen, as I said before, the exploration of the moon has provided great scientific understanding. It was an important component of the Cold War, and the effort to get us back to the moon is underway. I know Europe is spending a great deal of effort in thinking about that, more so probably than we have in the United States recently, but still there is some momentum for the international community to come together for a return to the moon, and I certainly think that's appropriate. These are the men who have been there. And you've already had a chance to gaze upon that. Thank you very much.
Interesting speech. As a matter of fact, I thought about you a few days ago.
Uh-oh.
Because it was a very nice evening, and I was enjoying some moonshine. Not the drink, the moonlight, I should say.
Oh,
the homemade
of course.
drink.
I understand.
And then I realized that we should all be very, very grateful to you. As being the last man on the moon, being the last man in office, you didn't turn off the light.
No, I hope not. I certainly didn't want to. Thank you. Thank you.
So we have a little present. Once again, thank you very, very much for an interesting speech.
Look at that. Appreciate it.
Thank you.
Thank you.
Well, ladies and gentlemen, Professor Schmitt, thank you for this wonderful speech you had to us. Since I'm a retired flight attendant, used to work for a major airline here in Europe, I want to ask you, how was the service on the trip to the moon? If we had a flight to the moon, which we didn't have, we wouldn't serve hot dogs and peanut butter. Well, I would think, Professor Schmitt, that the questions that we have, I'm sure we have some questions about this trip to the moon.
Happy to answer them.
Yeah, can we take that to the coffee after the dinner?
Of course.
Okej. Everybody, mina damer och herrar, välkomna upp, två trappor upp. Och där finns placeringslistor. Ni vet redan vilka bord ni sitter vid. You already know where you're supposed to sit. Welcome up, ladies and gentlemen.